Hi everyone, this is going to be the answers to your questions that you guys have on lesson 53 for Algebra 3. Now, I'm going to start with the only question that I received on the video, which was for lesson 53, number 23. After I'm done doing this problem, I will go through some of the other problems from lesson 53 with you guys. I forgot to clarify that for questions to be answered, I need you guys to post those questions in the comment section by 9 a.m. of the day that I am going to be posting those questions. So for example, the questions for lesson 54 are going to be posted in the link of this video or in the comments of this video, and those will need to be posted by Monday at 9 a.m. Now, if you don't want to wake up in the morning, you can post those questions the night before, or you can start posting them today. But all of those questions need to be posted by 9 a.m. Normally, I'm only going to do the questions that people ask for. Today will be the exception since I did not clarify by what time you needed to post those questions. So what we're going to look at right now is going to be lesson 53, number 23 is the first one that I'm going to look at. So for this lesson, we're going to start with y is equal to, and this is going to be 2/3 to the power of 3x minus 2. So the first thing that I'm going to do is I'm going to make an x and a y chart to solve. So I first want to know, where is this going to cross the y-axis? So I'm going to put x is equal to 0. Then what I'm going to do is I'm going to multiply, well, if I multiply this by 1/3, that would be 3 times 1/3 would give me 1, so that's a whole number. So I'm going to do 1/3, and then I'm also going to do 2/3. So if I plug in 0 into this exponent, I have 3 times 0, which is 0 minus 2. So 2/3 to the minus 2 would actually mean we take the reciprocal and square it. So that would be 9/4. And I want to put this into a decimal number so that's easier for me to graph. So that would be 2.25. Then I'm going to try and plug in 1/3. So 1/3 would make this, 3 times 1/3 would be 1, minus 2 would be -1. So I'd have 2/3 to the -1, which all that does is flip it, and that would be 3/2, and that would be 1.5. And then lastly, I'm going to plug in 2/3. So 2/3 would be 2/3 times 3 would be just 2, so 2 minus 2 would be 0. So 2/3 to the 0, and anything to the 0 power is equal to 1. And now I'm going to graph. So this one's going to be a little bit tricky to graph because I have decimal numbers. So I'm going to do my 1 is that far apart, then 1, 2, 3. So 0 up 2.25 would be about there. 1/3 would be probably about here, and that's up 1.5. And then 2/3 would be about here, and that would be up 1. So your diagram is going to look something like this, where it crosses the y-axis at 2.25. And that would be your answer for number 23. So that's number 23 on that lesson. Thank you to Jonathan for asking that question. And now I'm just going to go through some of the problems from this lesson as well. I'm going to skip the ones that I've already done in the lesson. That is posted in the lesson 53 new lesson video. And then I'm just going to work on some problems from this lesson at this point. So now I'm going to look at number 1. Number 1 says, if no repetition is permitted, how many ways can the digits 1, 2, 3, 4, 5, and 6 be arranged 4 at a time to form an even number? So I'm going to draw 4 boxes. When it forms an even number, that means the last digit has to be even. So 4 at a time, 4 boxes to form an even number. That means the units digit has to be even. When repetition is not permitted, we always have to start at the place that has the most conditions on it, and that would be our units digit. So I'm only choosing from the even numbers, which would be 2, 4, and 6. So I have 3 options. But when no repetition is permitted, I have to get rid of those values. It doesn't matter which one, you're just going to choose one of them. So I'm going to cross out 2. Now I'm going to go out to the thousand spot. Now, how many digits do I have left to choose from? Well, I've used one of them in the unit spot. Now I'm left with 1, 2, 3, 4, 5. There's 5 digits to choose from. Once I've used one of them, I can cross it out. Then I'm left with 4, and then I'm left with 3. So when I do this problem, you're going to multiply from left to right. So 5 times 4 times 3 times 3. And your answer would be there are 180 ways that we can rearrange these 6 numbers so that it forms an even digit or an even number. Now we're going to move on to number 2. So number 2 says a horse runs through an arc of 270 degrees along a circular racetrack whose diameter is 4,000 meters. How far does the horse run? So for number 2, we have our horse here that's running around a circular track. The diameter is 4,000. And it's a 270 degree arc, so actually that would be most of the circle. So this would be the distance that we would be calculating all the way around to here. And the formula for this distance is equal to x degrees over 360 times 2 pi r, or x over 360 times pi times diameter. It doesn't matter which one you use, but for this case, because they give us the diameter, I'm probably going to use that equation. So our x degrees would be 270 degrees over 360 times pi times my diameter, which they give us is 4,000 meters. Now you do want to multiply this out fully in your calculator. So using your calculator, you would do 270 times pi times 4,000 and then divide that by 360, which will give us a distance of 9,424.78 meters, and that would be your answer. Now I'm going to move on to number 3. So number 3, it says Moodog can do 8 jobs in 3 days, and Jimmy can do 5 jobs in 2 days. 39 jobs are need to be done. Moodog works 3 days, and then Jimmy joins in. How many days will both of them have to work together to complete the 39 jobs? For this one, it's going to be 2 people working together. So we have RMTM, rate of Moodog, time of Moodog, plus rate of Jimmy, time of Jimmy is equal to jobs. Now they give us the rate of Moodog. They can do 8 jobs in 3 days. So the rate is going to be 8 over 3. Then it says that Moodog works for 3 days and then is joined by Jimmy, which means that Moodog's time is going to be the time he works with Jimmy plus 3 days. Then we go to the rate of Jimmy, which is 5 and 2, so 5 over 2. He's only working with Moodog, so we're just going to do 2, and they're trying to do 39 jobs. Now, to get rid of the fraction, what we're going to do is we're going to multiply this whole thing by 6, which means you're going to end up multiplying that by 3 and this by 2. So when you multiply, distribute this through, it's actually going to be 2 times 8, which will give me 16t. And then I have 16 times 3, which is going to give me 48, plus 15t is equal to 39 times 6, which is 234. But I'm going to move the 48 to the other side by subtracting it. Add the t's together, which gives me 31t. Subtract 48 from 234 gives me 186. And then when I divide by 31, it tells me that the time that they're going to take to finish these jobs is going to be 6 days. And this is how long both of them are going to work. Now, if they ask us in total how long they worked, we know that Moo Dog worked for 3 extra days, so we would add 6 to 3. But this one's only asking us for how much they worked together. Now, moving on, we're going to look at number 4. So number 4 says, in a factory, M workers work 8 hours to do J jobs. So I have workers, I have hours, I have jobs, which means I'm going to use the formula rate times time times workers equals jobs. Now it says M workers, H hours, which means that time is going to be H, workers is going to be M, and the jobs is going to be J. So the rate is going to be equal to J over HM. Now we're going to use this formula again. So rate times time times workers equals jobs. We now know our rate is going to be J over HM. But it says that P new workers are hired. So our workers is going to be our original M workers plus the P new hires. And we're solving for time. But I have M plus P workers, and they're still doing J jobs. So now I have on the left-hand side, J times M plus P over HM times T, which I'm trying to solve for, is equal to J. So to get that T by itself, I'd multiply by the reciprocal of HM over J times M plus P. What you should recognize is that these two J's are exactly the same, so they actually cancel out. So your time is going to be HM over M plus P, and this is going to be hours. Okay. Now moving on to number 5. It says fast Francie could run Y yards in S seconds. This is a distance equals rate times time problem. What would her rate in yards per second be if she ran 3 times as far in 20 more seconds? So our original distance is going to be Y yards. Our original time is going to be S seconds. Because we know her distance and her time, we know that her rate is going to be distance divided by time, so Y over S. We're now going to do new distance because it says that she's going to run 3 times as far. So from her original distance, she's going to multiply that by 3 because she's going 3 times as far. And then it says 20 more seconds. So her new time is going to be her original time plus 20 seconds, which means that her new rate, solving the same as you would for a rate, is distance 3y divided by time, which would be S plus 20. And that would be in yards per second would be your answer. Okay, now moving on to number 6. This is actually a unit multiplier problem for number 6. So it says Kelly converted 2,800 francs to dollars at an exchange rate of 350 francs to the dollar. Then he went to another country and converted back to francs at 400 francs to the dollar. What was his profit in francs? So I'm going to start with my 2,800. I'm going to do francs. Then I'm going to use the first unit multiplier they give us. They give us 350 francs to $1. So it would be $1 to 350 francs. So I know my francs would cancel. Then it says we're going to convert back to francs at 400 francs to $1. So if dollar is at top, I have to put it at the bottom. So that means my 400 francs would go at the top over my $1. And now my dollars would cancel. So now we're going to find out how much francs we have now. So I would do 2,800 times 400. Then I would divide that by 350, which would give me 3,200 francs. But we started with 2,800. So now I'm going to find out the difference, so how much he profited. So subtract our original 2,800 from that, and that gives him a profit of 400 francs. So this is one of those concept review problems that you wouldn't be tested over, but it is just reviewing your unit multipliers on number 6. Number 7, 8, and 9, we're done in the lesson 53 lesson. So if you do not know how to do those, please go back to the lesson 53 video. And now we're going to look at number 10. Number 10 gives us sine of theta is equal to root 3 over 2. Now I have my chart here, which gives me all students take calculus. So what I'm looking for is where sine is positive, because this ratio is positive. I know that everything is positive in quadrant 1, but I also know that sine is positive in quadrant 2. My ratio is opposite over hypotenuse, so this would be opposite side would be root 3, and my hypotenuse will be 2. This is a reference triangle with square root of 3 and 2, so I know that my adjacent is going to be 1 and negative 1. And now I just have to solve for that degree. So for the first one, in quadrant 1, it's just going to be 60 degrees because that's in quadrant 1. In quadrant 2, this is still a 60-degree angle, but I want to know the distance from 0 degrees to that point. So I'd have to subtract 60 from 180, which would give me 120 degrees. And that would be my answer for number 10. Now moving on to what number 11 would be. Now what I want to do first for number 11 is I actually need to move the 1 to the other side, which would give me cosine of 3 theta is equal to positive 1. Now I know that there is no reference triangle that has a adjacent of 1 and a hypotenuse of 1. So that's not going to be a reference triangle. We're actually going to need to use our unit circle. So I'm going to draw my unit circle here. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now cosine is equal to the x-coordinate. So I'm going to underline all my x-coordinates. Now if you look at this chart and all the x's that I just underlined, there's only one place where my x-coordinate is equal to 1, and that's at 0 degrees. Now, don't forget your inviolable argument, which tells us that there's going to be 3 answers for each place that satisfies this equation. And this is only going to be 3 answers. So I'm going to set 3 theta equal to 0 degrees. Now, if I divide both sides by 3, my first answer is going to be that theta is equal to 0 degrees. But I know I have to have 3 answers. So I'm going to set my 3 theta equal to 360. Divide both sides by 3, and that would give me theta is equal to 120. Now, this isn't always going to be a part of your answer, but this is what you're going to continuously add so that you end up with 3 answers. So I already know my first answer is 0. My second answer is going to be 120, because if I add 0 and 120, I get 120. And when I add another 120, that's going to give me 240. So my answers are going to be 0, 120, and 240 for number 11. Now again, that's 3 answers that will land us between 0 and 360. These are all between 0 and 360. Now remember this, because when we go to number 12, I don't have it written there, but we have sine of theta over 2 minus 1 is equal to 0. So just like on the last problem, I'm going to move the 1 to the other side to give us sine of theta over 2 is equal to 1. Just like on the last problem, again, we don't have a reference triangle that has an opposite of 1 and a hypotenuse of 1, so I'm going to use the unit circle. And this time, I'm not looking for the x-coordinate, but I'm looking for the y-coordinate, because sine is equal to the y-coordinate. So I'm going to underline all my y-coordinates. And I notice the only place where my y-coordinate is equal to 1 is at 90 degrees. But don't forget about this inviolable argument right here, this theta over 2. So I'm going to set my theta over 2 equal to the only degree that I have, which is 90. Now, if I multiply both sides by 2, my only answer is going to be theta is equal to 180. And the reason that is because if we remember our trick, we would set the theta over 2 equal to 360. And once I multiply that by 2, that's going to be 720. But remember, our parameter is that it has to be between 0 and 360. So 720 is out of that parameter. So therefore, that cannot be part of our answer. So our only answer is going to be that theta is equal to 180. Now moving on to number 13. Number 13 and 14 are both problems that we learned when we started talking about our logs and natural logs in the calculator. So for number 13, it says that we need to write 6,200 as 10 raised to a power. So that means I have 6,200 is equal to 10 raised to a power. And this is where my answer is going to be. Now, if my base is 10, we're going to use the log button. So in your calculator, you plug in 6,200, and then you're going to press the log button. So that would be 3.7924. Remember, you go to 4 decimal places, not just 2. Now, if you want to check your answer, you leave your answer there, and then you hit the second log button, and look at that. It gives you 6,200. So that is your answer right there. Now for number 14, well, we used the log button if our base is 10. For number 14, we have 5,400, but we're having it as e raised to a power, which means that instead of the log button, you're going to use the natural log button, the ln button. So 5,400 ln, and it would be 8.5942. Remember, you go to 4 decimal places and not just your normal 2. And again, you can check your answer by hitting the second ln button, and again, it gives you 5,400, and that would be your answer. So that would be e to the power of 8.5942, and then 10 to the power of 3.7924 gives you your answer. Now we're going to look at number 15. So for number 15, I have my f function is going to be cotangent. My g function is secant. So for number 15, I have cotangent squared of negative pi over 3, and then minus secant squared of 0. So negative 1 means that we're going to end up in quadrant 4. So I'm going to draw a triangle in quadrant 4. Because the denominator is 3, I know that it's a 60-degree triangle, which means my adjacent is 1, my opposite is negative root 3, and my hypotenuse is 2. Cotangent is the inverse of tangent, so that would be adjacent over opposite. 0 is actually using the unit circle at 1, 0. And secant is the inverse of cosine, so that will be 1 over the x-coordinate. So now if I go to my triangle, I have adjacent over opposite would be negative 1 over the square root of 3, but I would have to square that because it's cotangent squared. Then at the x-coordinate at 0 degrees, that's actually just 1, so 1 over 1 would be 1, so 1 squared. And again, you square it because it's secant squared. Now 1 over root 3 squared would give us 1/3 minus 1, which we would make a common denominator, meaning that your answer is going to be negative 2 over 3. Okay, now moving on, we're going to look at number 16 on lesson 53. So we're just continuing to work on this lesson. I'll flip my paper here. Again, my f function is going to be secant squared. My g function is going to be cosine squared. So I'm going to input these variables. So this would be secant squared of negative 3 pi over 4 plus cosine squared of 13 pi over 6. Now what I'm going to do is I'm going to make my snowflakes here. So denominator of 4 would be 1, 2, 3, and 4. Then 1, 2, 3, and 4. And for 6, so it'd be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Now starting at 0 for negative 3, again, if it's a negative value attached to your pi, you're going to go clockwise starting in quadrant 4. So 1, 2, 3. That puts us in quadrant 3. Anytime the denominator is 4, it's a 45-degree triangle, and you can remember that by doing 180 divided by 4. So my adjacent's going to be negative 1, my opposite's going to be negative 1, and my hypotenuse is going to be the square root of 2. Secant is the inverse of cosine, so that's going to be hypotenuse over adjacent. Now for 13 pi over 6, that's a positive 13. So I'm going to go start in quadrant 1 at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And that puts me back in quadrant 1. And anytime the denominator is 6, it's a 30-degree triangle. So the adjacent would be square root of 3, my opposite would be 1, and my hypotenuse would be 2. Cosine is the ratio of adjacent over hypotenuse. Now I'm going to look at my two triangles. So secant squared, so hypotenuse over adjacent. Hypotenuse over adjacent would be negative square root of 2, but I'd have to square that because it's secant squared. Then adjacent over hypotenuse would be square root of 3 over 2, and I would have to square that as well because of the cosine squared. So now square root of 2 squared is just going to be 2 plus 3 over 4, and you want to make a common denominator of 4. So your answer is going to be 11 over 4 because 8 over 4 plus 3 over 4 would give you 11 over 4. Okay, and moving on, we're going to look at number 17. So number 17, it says write the equation of the line equidistant from the points 8, 4 and negative 3, 4. Using the locus definition method, write the equation in general form. So the locus definition method is going to be the form x minus x1 squared plus y minus y1 squared equals x minus x2 squared plus y minus y2 squared. So now this is my x1 and my y1, so that would be x minus 8 squared plus y minus 4 squared equals, this would turn into plus 3 because when you put negative, negative, that would be plus 3 squared, and then y minus 4 squared. Now I'm going to multiply this out. So you get x squared minus 16x plus 64 plus y squared minus 8y plus 16 equals x squared plus 6x plus 9 plus y squared minus 8y plus 16. But what you should see is that all your x squareds and your y squareds are going to cancel out. There's also a positive 16 on both sides, and the negative 8y's would cancel. So really, all we need to do is put this into general form, which means to set everything equal to 0. So I'm going to subtract my 9 and subtract the 6x, so that you end up with negative 22x plus 55 equals 0. Now what I would do to simplify this is that it's all divisible by 11. Divide the whole thing by 11, so you get negative 2x plus 5 equals 0. And again, there's no y because the y's on both sides actually cancel. So now we're going to look at numbers 18 and 19 on this lesson, and those are both going to be your two sinusoids. So what you need to look at here is we need to first determine what type of graph this is going to be. So if I look at number 18 first, notice that it is peaking at the origin. It's peaking at the origin, which means that it's going to be either a positive or a negative cosine function. I notice that it peaks, so that means I know that it's a positive cosine function. So the equation that you're going to start with is y equals a plus b cosine of x. That's the equation you're going to start with. Now your a is going to be your middle value. So in this case, our middle value is going to be 1. So my a is equal to 1. My b is my amplitude. So the difference between the top and the middle value. Difference means we subtract. So you would do for b, you'd have 6 minus 1, which would give us 5. So my answer is going to be y is equal to a, which is my midline, plus b, which is 5 cosine of x, and that would be your answer. Now looking at the second one, this one is going down at the origin, so one of them on the left went up, one of them went down at the origin. It's not crossing through. So again, I know that this is going to be a cosine function. So this would be y is equal to a minus b cosine of theta. Now I need to find what the midline is going to be on this one. So if you notice, the midline on this one is right here. The middle value is actually negative 1. So that means my a is going to be negative 1. Now b is going to be the difference between the top and the middle value. So difference means you subtract. So it'd be 6 minus negative 1, which gives me 7. And therefore, that my answer is going to be y is equal to negative 1 minus 7 cosine of theta. And that would be your answer for numbers 18 and 19. So making sure you know what the difference between a sine and a cosine curve are, and then also how to find your a and your b. So a again is where the x-axis is crossing the y-axis, and then b is the difference between the top and the middle value. Now we're going to look at number 20. So write the quadratic equation with a lead coefficient of 1 whose roots are negative 1 plus 2 root 2i and negative 1 minus 2 square root of 2i. So the way you're going to solve this one is by using the formula x minus root times x minus root equals 0. Now when you plug in these roots, you want to make sure to flip all of the signs. So this first one, the 1's going to become positive. The 2 root 2 is going to be negative 2 root 2i. Again, this negative 1 is going to turn into positive 1. And the 2 root 2i is going to turn into positive 2 root 2i. Now I do need to multiply this out fully and then simplify. So x times x would be x squared. X times 1 would be x. X times 2 root 2i would be 2 root 2i x. Negative, it would be 1 times x would be x. 1 times 1 would be 1. 1 times 2 root 2i would be 2 root 2i. Then the last would be negative 2 root 2 times x. So that would be negative 2 root 2i x. Negative 2 root 2 times 1 would be negative 2 root 2i. And then negative 2 root 2 times 2 root 2i would be negative 4 times 2 times negative 1, because 2 times 2 is 4, root 2 times root 2 is 2, and I times I is negative 1. So now I'm going to go through and add my like terms. So I can add my x's together. I also recognize that there's a 2 root 2i and a negative 2 root 2ix. Those cancel, as well as my 2 root 2i and my negative 2 root 2i. And then I have 1, and this n value right here, negative 4 times 2 times negative 1 would actually be positive 8. So 8 plus 1 would give me 9. My answer is going to be x squared plus 2x plus 9 equals 0. And if you wanted to check your answer on this, you could actually do quadratic formula. And when you do quadratic formula, you actually would end up with these two as your answer. Number 21 is a skip problem, so you don't need to do that one. Number 22, we're finding the standard form of the equation of a circle whose radius is 5 and whose center is at root 3 and negative 2. Now this formula for the standard equation of a circle would be x minus x1 squared plus y minus y1 squared equals r squared. So when you input your values, make sure you change the signs. So that would be x minus the square root of 3 squared plus y plus 2 squared is equal to the radius squared, which would be equal to 25. And that would be your answer. Now number 23, we already did at the beginning of this video. So we'll move on to number 24. Number 24. So anytime you see a minus sign between your two logarithms, you know that you're going to divide those two variables. So we would have log 15 of 4 over 2 over x is equal to 2. Now to get rid of this log 15, I'm going to raise both sides to the power of 15, which means that the log 15 cancels, but on the right-hand side, I would have 15 squared. Now this would be 4 over 2 over x equals 15 squared, which is 225 over 1. Now you're going to cross multiply these so that you would have, well, when you multiply 225 times 2, you would have 450 over x is equal to 4. But then again, you're going to cross multiply so that you end up with 4x is equal to 450. And when you divide 450 by 4, your answer is going to be x is equal to 112.5. Or you could leave it as a fraction. Then looking at number 25, if there is a number outside your logarithm, which we have twice, that means you raise it to, or you bring it to the power, to the exponent. So I'm going to move this 2 to the power of 4 and the 2/3 to the power of 8. So that would be log 7 of 4 squared minus log 7 of x equals log 7 of 8 to the power of 2/3. Now I see this minus sign, so I do have to combine the logarithms on the left-hand side. And again, anytime you see a minus sign, that means you divide. So this would be 16 divided by x equals log 7 of, and you can do this in your calculator, so the 8 to the 2/3 part, you would do 8 to the power of, just put it in parentheses, so 2 divided by 3, end parentheses, then hit equals, and it tells you that that's going to be equal to 4. Now to get rid of the log 7 on both sides, we raise it to the power of 7, so 7 to the log 7. And now we're left to cross multiply, so that would be 16 over x is equal to 4 over 1. Cross multiply that would give you 4x is equal to 16. So therefore, x is equal to 4. And that would be 25. Now this is actually number 26 in your lesson. I just labeled it wrong. So this says to determine if f of x is equal to 1 over 1 minus x and g of x is equal to x minus 1 over x are inverse functions by computing their compositions. So I know that in order for them to be inverse functions, their compositions have to be equal to x. So what I'm going to do is I'm going to start by computing the f composite g of x. So f of g of x. I know that my g of x is equal to x minus 1 over x. Oops. So now I'm going to plug this into the f function. So that means wherever you see an x, you replace it with this. So that would be 1 over 1 minus x minus 1 over x. Now I want to add these together by making a common denominator of x. So that would be 1 over, that would turn into x, distribute the negative sign, so that would be negative x plus 1 all over x. Now you should see that these two x's are going to cancel. Now to get rid of the complex fraction, you multiply top and bottom by the reciprocal, which means that my composite is equal to just x. Now you're not done because both composites have to be equal to x in order for them to be inverse functions. So I now have to go and compute g composite f of x. I know what my f of x function is. It's 1 over 1 minus x. And that means I take this and replace all the x's in my g function with that entire function. So that would be 1 over 1 minus x minus 1 over 1 over 1 minus x. Now again, just like on the last one, I want to add these two fractions in the numerator by making a common denominator of 1 minus x. Now when I distribute that negative 1, I'm going to have 1 minus 1 plus x over 1 minus x over 1 minus x. Now to get rid of the complex fraction, just like on the last one, you multiply by the reciprocal of 1 minus x over 1. And that would cancel, as well as my 1 and negative 1, so I am just left with x. Since they're both equal to x, your answer is going to be yes, they are inverse functions, and that's number 26. Now moving on to number 27, it says in the figure shown the trapezoid whose area is 6 centimeters squared, find x, dimensions are in centimeters. So I have a diagram here where my height of my trapezoid is going to be x. Then I have 2x minus 3 up here, and then I have 3x minus 1 in the bottom. And the area is equal to 6. Now the area of a trapezoid is 1/2 the height times base 1 plus base 2. Now my area they give us is 6. The height they give us is x. My base 1 is going to be 2x minus 3 plus 3x minus 1. Now if I multiply this whole equation by 2, that will get rid of the fraction. So that would give me 12 equals x times 5x minus 4. Now if I set this equal to 0 and distribute my x, I get 5x squared minus 4x minus 12. And now to solve for x, you have to do either quadratic formula or you have to complete the square. I'm going to do a quadratic formula. So a, b, and c. So x is going to be equal to negative 4 plus or minus the square root of negative 4 squared minus 4 times A times C all over 2 times A. Now 2 negatives are going to make a positive over 10 plus or minus. Now if I do this in my calculator, well, I have negative 4 times 5 times negative 12. So 4 times 5 times 12. I'm going to add that to 16. So I would get the square root of 256 over 10. The square root of 256 is actually equal to 16. So really what I have is 2/5 plus or minus 8/5. 2 plus 8 is 10, divided by 5 would be 2. 2 minus 8 would be negative 6 over 5. Now remember, your height was x. Your height can never be negative. So therefore, your only answer is going to be that x is equal to 2. Now moving on, we're going to look at number 28. So number 28 is right here. It says the graph of the function f of x is equal to x squared is shown on the left below. The graph on the right is the same graph reflected on the x-axis and translated 4 units up. So this is going to go 4 units up, but it's also mirroring down on the x-axis. It's mirroring down on the x-axis, which means that all of your outputs are now going to, or all the x values are going to stay the same, but everything that you get on the output is going to be negative because it flips down. So all your y's become negative, which means that when it mirrors on the y-axis, your whole function actually becomes negative. So my new function, g of x, will be this same function, x squared, but negative because it mirrors down. And it also moves up 4 spaces. So it mirrors down, so therefore makes the function negative, and then it's also moving up 4 spaces. Now looking at numbers 29 and 30. So number 29 says, let f of x equal x squared and g of x equal x squared minus 3. Which of the following statements must be true? Well, our x isn't changing, so I know that this is not going to be shifting on the x-axis. So this left and right is not going to be right. It's not going to be A or B because it's not shifting on the x-axis. But I know that the outside is changing, which means it's shifting on the y-axis. And since this is a negative 3, that means it's moving down 3. So therefore, your answer is going to be D. The graph of G is the graph of F translated 3 units down. Your X is not changing, therefore it's not moving on the X-axis. But because there's a minus 3 on the outside, that means it's moving down 3 spaces on the Y-axis. And now looking lastly at number 30. So number 30, we have to start by sticking our x plus h into the f of x function. And then I'm going to stick my x minus h into the f of x function. So I'm going to start with just the f of x plus h. I'm going to input the x plus h into wherever I see an x in the f of x function. So that's going to be done in black. This is my f of x plus h. Then I have my minus sign, and this whole thing is going to be over 2h. So this is going to be my whole function. That's in green. And then in blue is where I'm going to input my x minus h. So that would turn into x minus h squared minus x minus h. So I'm going to actually put this inside of a bracket. Now I'm going to multiply this through. So if I multiply out x plus h times x plus h, it's going to get very long. So it's going to be x squared plus 2xh plus h squared minus x minus h. That's going to be my first part. This is the part done in black. Then I'm going to do minus the part in blue. So this is going to be x squared minus 2xh plus h squared minus x plus h. And that's all going to be over 2h. Now that I've done that, I'm actually going to make this into one function. So I'm going to just distribute the minus sign into that parentheses, leave everything else the same. So x squared plus 2xh plus h squared minus x minus h minus x squared plus 2xh minus h squared plus x and then minus h, and that's all going to be over 2h. So now what you need to do is you need to go through this whole thing and see what simplifies. Well, my x squared and negative x squared would actually cancel out. My h squared and my negative h squared would cancel. My negative x and my positive x would cancel. I can actually combine my 2xh and 2xh and combine my negative h and negative h. So that would give me 4xh. And negative h minus h would be negative 2h. That's all over 2h. Now I look in the numerator and I can actually factor out a 2 and an h. And when I do that, I'm left with 2x in the first term and then 1 in my second term. And that way my 2h's on top and bottom would cancel, and you would just be left with 2x minus 1. And that is the entirety of lesson 53. So that should encompass all of your questions. In the comments of this video is where you are going to list any questions that you have on lesson 54. And those questions need to be posted by 9 a.m. on Monday morning. I will then post the video for lesson 54, which is due that day. Don't forget that your stamp for lesson 54 is due today by midnight, and lesson 53 is due by midnight tonight as well. I hope you guys all have a great day and have a wonderful weekend, and I'll see you guys again on Monday.